Hi, welcome to this new tutorial. We will be seeing how to convert a regular texture like this into a Vitraux. We can achieve this by altering the texture coordinates. We can do it in cells like this, or in this case, if we use, for example, this is a pack with smart masks and textures that I am working on. And this is, for example, a way to pixelate an image. We can see how if we decrease this, we get bigger pixels. This also works for procedural textures. As you can see, I'm using one that breaks the texture in hexagons, like a honeycomb. And you can basically do this with any shape you want. So if you're interested, let's get started. Okay, let's start by adding a plane. I will go to my shading tab. And the first thing, I will go to my world and I will add an HDRI. If you're using Node Wrangler, you can select this node and Ctrl T. And it will add everything at once. Okay. Now if I go to my render view, I can see the HDRI. In this case, I want to see the background because I will do a glass and I want to see through it. Let's go back to object here, create a new material. And I will use 7 on my numpad to go to top view. Now I will add a texture coordinates. And the first thing, I want to explain a bit how the coordinates work with an image texture. I'll use UV. The first thing is to understand what's going on with UV. If we go to UV editing, we see that we have an image there, and the area of the UV has a 2D coordinate that goes from 0 in this corner and grows to 1 on X to the right and to 1 on Y to the top. So this will be 1X, 1Y, and this is 0 for both. So for example, let me show you UV. Sorry, this is what we have here. 0 to 1, 0 to 1 in green, and the yellow is the mix of both. If we go to UV and we move something, for example, this point, we move it here, you will see how the color changed because the values changed. Now my bottom right part of the plane, it's no longer at 1x, it's at 0.5x and 0.5y, more or less. So that's why we see here this color instead of something closer to red. So that's just to understand what's the output of the UV. That depends on this. And also when you use UV on an image, let's see, for example, we have this. If we change this, now on my corner there, this will deform, of course. We will see how on the corner there's this part of the helmet, and you can see that's what we have here. So the UV is telling to the image, take the bottom left part of your image, and point by point, it's assigning a coordinate to place this image here. Okay, so if we deform this UV, we can deform the way the image is mapped. For example, if instead of a linear increase in value here, if we alter this, I will use vector math. And I will use snap here. With snap, the value will only change in increments of the number I put here. So for example, if I take this is not important because in UV we don't have a C value. So I will change these two to 0.1. And now the values won't change until they reach an increment of 0.1. So the first point is repeated because it's always 0, 0, 0, 0. Then it reaches 0.1, so it changes value and changes to 0.1. So it takes that point, and this entire square here has the same value, so it repeats the same point. That's why it has the same color. These lines that you can see sometimes in between the squares, you can change this from linear to closest and it will disappear. If you want a smaller size pixel, you can, for example, change this to 0.01. So basically that's what we are going to do, but a bit more complex. So in this case, we are going to use Voronoi texture. And the interesting thing about this texture is that you also have two other outputs. This one you already probably know it. But here you have the color. This is a random color per cell. And here you have the position. In this case, it's using, as you can see, there's a little bit of blue also because it's using generated here by default. And you can change it to UV. Now this is UV, and you can see like the position is entire cell has the color corresponding to that coordinate. So in this case, you have this value of red at this point and this value of Y, and the entire cell takes that color. So that means that we can use that as a vector for our image. And as you can see, if we make the cells smaller, we can start to see the image, but always respecting the cells. As you can see, this is using 3D. So the cells that make this texture that you can see here are changing value in Y, X, but also on Z. So when they move like forward and back from this view, they can get, if this is just like the tip, it becomes really small. So you can change this to 2D depending on what you're doing, and you will see how the cells are a bit more even in size. Now to create the borders here, I want to use another Voronoi texture because I will use distance to edge, but this doesn't have the outputs I want. As you can see, I want to use this texture, so I will duplicate this. If we keep them at the same scale and randomness, the cells will match. So even if I change this back to F1, for example, this will match this. So I want to use a value node and plug it to both scales, and also same vector. Now I want this to be my border, so I will use a map range. And I will take my 0 to maybe 0.2. Distance to edge has a 0 value on the edge and grows as it gets further away from every edge. So if we use the value from 0 to some number, we will have like a border here. I will use 0.2. Now I have a 0 to 0.2 becomes my 0 to 1. And everything beyond 1 will still be 1 because I'm clamping the value here. If I unclamp this, it will still keep growing to maybe 2 or whatever, but I won't use that. And now I want to invert this because I want my border here. So I will change this to 1 and this to 0. And now I can control this thickness with this number here. So I'll make this maybe out there. Now I want this will be my image. And I want to mix them. I will use glass. And if you are using Node Wrangler, you just press Ctrl 0 on your numpad. And you will have the mix shader there. I will plug this on the bottom. I will use a bump. Plug this on the height and change the distance to maybe 0.01. This will be something like that, maybe. And we need our factor will be math node greater than. So everything that has a value greater than 0 will become completely white. And we plug this here. So now we have our mask. We can plug it here. Okay, now we have this, and I will rotate the next 90 so we can start seeing this. Since this is glass, we need something behind to see how it behaves. And I will use a bit of roughness. So something like that maybe. And for the color, we will use our texture here. And we start getting this. Now we can still control the thickness of this border here. And also the size. There. And here you can control the roughness of the glass. And also if you want, you can enter edit mode and extrude a bit to create this thickness. You can also use this to affect other textures, like for example a noise texture, classic. I will use the position as the vector. And as you can see, the noise respects these cells too. And you can use the same with pixels. So you have a noise that respects this pixelation. That works for everything. I hope you have enjoyed this tutorial, and see you on the next video.